Okay, so now the back side of the second sheet, the velocity versus time graph on the back side. Remember in this one, the slope of the line is the acceleration. To get the velocity at any point, you just read it off the graph. Average velocity, though, you would still do VAV equals the displacement over time, or average speed, distance over time. And this is the one where if you want distance and displacement, you have to find the area. So what was the maximum velocity achieved by the cart? Well, it was positive 6 meters per second here, negative 6 meters per second here, positive 6 meters per second there. So you're going to say 6 meters per second east and west. They will not always be two answers. What is the velocity at the 10-second point? So you go to the 10 seconds, you go down. This point, I would say it's probably like 3 meters per second, and it's negative, so west. During which times was there constant velocity? There's constant velocity whenever the slope is horizontal. So from 12 seconds to 16 seconds, and from 24 seconds to 26 seconds. When was their maximum positive acceleration? So I think, again, like the other one, I won't ask you something like that, but it means when was the positive slope the steepest? Okay, so here it's going, so when was it accelerating at the greatest rate, whether that be speeding up or slowing down? Okay, so here in 4 seconds, it's gone up to 6 meters per second. Here in positive, so that's this one. Here in 4 seconds, it's gone up to, changed, increased its speed by 6 meters per second. And here as well. So the time intervals are going to be 0 to 4 seconds, so there's more than one. 0 to 4 seconds, 16 to 20 seconds, and 20 to 24 seconds. In all 4 of those spots, or 3 of those spots, it's accelerating. The slope would all be equal. Those would be the maximum positive, speeding up, slowing down in the negative direction, speeding up. During what time intervals were there zero acceleration? Zero acceleration when there's constant velocity. So between 12 and 16 seconds, and between 24 and 26 seconds. Exactly the same answer as above. What distance was traveled in the first 8 seconds? So now you need to find area. So I suspect most of you divided this triangle into 2 triangles. The base here is 4 meters. The height is 6. 6 times 4 is 24. And take half of it, it's 12 meters. This guy is identical. Base is 4. Height is 6, so that's 24. Take half of it, that's 12 meters. They are both positive, so they are both east. So how far did it travel? In the first 8 seconds, 24 meters east. What is the acceleration from 0 to 12 seconds? Well, it's 0, again, it's find the slope, and really you're going to find the slope of the line that would be connecting these. Right? So this ordered pair is 0, 0, and this one is 12 seconds and negative 6 meters per second. And so you do the slope, I don't know where I went, right here. So negative 6 meters per second minus 0 over 12 seconds minus 0 seconds. On the top will be negative 6, on the bottom positive 12. That gives you a negative 0.5. So 0.5 meters per second squared west. That's what the negative means. When did it first start to move west? Right here. Remember on a velocity versus time graph, above the line is positive, or east, below the line is west. So it first starts to move west at 8 seconds, and it doesn't start to move west again. It moves back east, but not west. Did the car ever return to its starting point? Well, to figure out that, we just found here that it went 24 meters east. So now we need to see, is there any point where it went 24 meters west? I'm going to switch colors to keep me straight. So you would need to find the area of this triangle. This is going to be west. Its base is 2, its height is 6. So excuse me, its base is 4, its height is 6. That's 24. It's a triangle. Take half. So this is 12 meters west. Then I might do this next little piece right here, these two, and find this area. Base is 2, height is 6. This will be 12 meters, and again it'll be negative because the height is really -6 west. So one of the points that it returns to its starting spot is at 14 seconds. But it might return a second time, so you have to keep going. This spot, so sorry, I know that because this piece then here is 24 meters west. So at 14 seconds, it's come back. So it went 24 meters east, now it's come back. This little rectangle is the same as the previous one. It's going to be 24 meters again west. And this triangle is the same as that one. It's going to be 24 meters west. So it went another 24 meters west before it changed direction again. So over here, if we do this triangle, base is 4, height is 6, half of 4, 24, half of that, 12 meters east. Oh, and look, there's that little triangle again, base of 2, height of 6, 12 meters east. So at this point as well, it has returned to its starting spot. So the two spots are 14 seconds and 26 seconds. And then it travels this little distance, base 2, height 6. It travels another 6 meters east after that. Okay? What was its acceleration at the 18-second point? So we need to find the slope. 18 seconds is here. I'd pick this point, and I'd pick this point. So this point is 20 seconds and 0 meters per second, and this one is, I think that's 15, but I've now written all over it. 14, 15, no, it's 16. So it's 16 seconds and -6 meters per second. And so find the slope. So I would probably start with 0 meters per second minus a -6 divided by, I started with the 0, so then 20 seconds minus 16. On the top is +6, on the bottom is +4. That's 3 over 2, or 1.5 meters per second squared. It's positive, so it's going to be east. Average velocity for the first 8 seconds. Well, we found the displacement, if you remember, to be 24. We did that from the area under the graph. So the average velocity is displacement over time. So the average velocity, or average displacement was 24 meters east. The time is 8 seconds, so this should be 3 meters per second east. So up here, 3 meters per second east. The average speed in the first 8 seconds, well, in the first 8 seconds it didn't change direction. So the average speed and the average velocity are actually going to be the same because the distance and displacement is the same. So it's going to be 3 meters per second, just drop the east. Average velocity for the first 12 seconds. For the first 12 seconds, it had gone 24 meters east and then 12 meters west. So its displacement will be 12 meters east. So 12 meters east, and it was in 12 seconds. So this should be 1 meter per second east. Average speed, 24 meters east, 12 meters west. That's 36 meters in total. That's velocity. So average speed, which is distance, 36 meters. And over 12 seconds, it should be 3 meters per second. And then the last question, no, not quite. Explain the motion at 14 seconds. Constant speed going west, 6 meters per second. Explain the motion at 6 seconds. Slowing down, going east. Okay, so there it is. Velocity versus time. I'm hoping these are getting better. I'm hoping.